Hi guys, NCWQ here, and as you can see, we have a new article, Hidden Earthquake Risk Found Lurking Beneath Los Angeles. And this is brought to us by National Geographic. And we're going to go over here, and we'll show this is California here, and we will be talking about Los Angeles, which is here. Anyways, this article reads, the magnitude 6.7 Northridge earthquake rocked Los Angeles in 1994, killing more than 60 people and injuring thousands. This trembler came from a rupture of what's known as a blind thrust fault, the same type of fracture in Earth's crust addressed in the new study. The fault was once thought dead, but recent research suggests it's likely still active and poses a hazard to the metropolis above. The ports of Los Angeles and Long Beach bustle with activity. Their colorful array of shipping containers are stacked and unstacked in a never-ending, multi-billion-dollar gamble of Tetris, but a previously overlooked danger lurks below this frenzy. A fault capable of generating earthquakes magnitude 6.3 or greater. The Wilmington Fault, as it's called, is an elusive type of fracture. Unlike many faults which crack Earth's surface like an egg, the Wilmington Fault is blind, which means it's concealed beneath the surface, making it especially difficult to study. So while scientists have long known the fault is present, stretching 12.4 miles under southern Los Angeles into South San Pedro Bay, it was presumed to have sat quietly for millions of years. Now, a new analysis of the system published in Bulletin of Seismological Society of America suggests that isn't the case. Using a cluster of clues incorporated into a three-dimensional model, the study authors posit that the fault has been active much more recently than once thought, and likely still poses a risk to people on the surface. I hope bringing attention to it can potentially increase safety in the region, says study author Franklin Wolf, a doctoral candidate who is part of Harvard's Structural Geology and Earth Resources group. While the fault is slow-moving and likely ruptures only once every 3,200 to 4,700 years, it underlies two of the United States' busiest ports. And researchers worry that the Wilmington could link with other nearby faults to produce a trembler as strong as magnitude 7.4. Earthquakes are unpredictable and can strike with enough force to bring buildings down. Find out what causes earthquakes, why they're so deadly, and what's being done to help buildings sustain their hits. The study also emphasizes just how many faults crisscross Southern California, adds Chris Goldfinger, an earthquake geologist at Oregon State University, who is not part of the research team. Scientists have made major strides characterizing the geology of the region, but there's still more to do. Just by itself, if you take the implications of a relatively slow-moving fault like this, it won't change the hazard very much, he says. But the discovery that the Wilmington Fault is likely still active, he says, sort of leaves this big hanging question mark. What about all the others? Tectonic smash-up. When most people think about California earthquakes, they think of the San Andreas Fault. The mighty feature formed some 30 million years ago as the North American plate swallowed almost all of what's known as the Farallon Plate. Ever since the North American plate has met face-to-face with the Pacific plate, the two grinding past each other at a boundary called a strike-slip fault. This sent North America for a wild ride. Its west coast first stretched out, then sections later compressed. That means the faults in the basin where Los Angeles sits today first slid in one direction and then reversed, forming thrust faults in which blocks of land are shoved on top of each other, on top of others. It's as if you put the whole thing in a vise and started turning the handle, said Goldfinger. One such thrust fault was the focus of this latest work, but it's still hidden below ground. Slow growing and breaking through soft sedimentary rocks, the Wilmington Fault hasn't yet breached the surface. Sorting out where we have these sneaky active faults is a challenge, said Kate Scherer, an earthquake geologist at the U.S. Geological Survey, who is not part of the research team. In urban LA, Buildings and roads make surveying difficult, and the lack of surface break adds another layer of complexity to the hunt for slow moving faults. Assembling the geologic jigsaw. By sending waves of energy that penetrate the ground and watching how they bounce back, a process similar to an ultrasound, researchers can examine the warping of different layers and read the rock's deep geologic past. Wolf explains the early versions of these Earth sonograms come from the oil and gas industry, which was interested in finding the ancient organic material trapped beneath the folded layers that would produce petroleum. These images revealed a distinct subsurface fold above the fault, which points to a period of early activity. As the basin is squished, stresses build until they hit a breaking point, and the earth gives way both as movement along the fault in ground rattling earthquakes, as well as enfolding the rock layers. Like the pages of a paperback that squeeze from both sides, said Kimberly Blisnewick, an earthquake geologist at San Jose State University who was not involved in the work. But these curved layers were capped with what seemed to be nearly horizontal rocks. That's what led to this idea that it's no longer active, said study author John Shaw, a structural geologist at Harvard University with extensive experience studying the complexities of blind thrust faults. Hints of a fold linger in the shallow rocks at the southern tip of the fault, Shaw says, but the instruments used in the oil and gas industry focus on deeper rocks, where petroleum is most likely to lurk. To know if the fault was recently active, they needed better images of the layers just below the surface. The next piece of the geologic jigsaw clicked into place at a conference about a decade back when Shaw ran into Dan Ponte, a co-author on the new study and geologist with the USGS. Ponte had been mapping groundwater near California's coast and noticed something curious. Some of the shallow rock layers of the aquifer were warped. He didn't have an immediate understanding or explanation of why that would be, Shaw says. Located near the Wilmington Fault, it was possible the folds in these shallow layers pointed to recent activity, but the direct connection between these two-dimensional slices of Earth and the overall fault structure hadn't yet fallen into place. That's where Wolf came in. As a first-year graduate student at Harvard University, he eagerly began compiling all the data he could get his hands on, including the recent USGS seismic profiles. Incorporating the information into a three-dimensional model, finally the picture was clear. It was all part of the Wilmington Fault, evil earthquake twin. From their analysis, the team estimates the Wilmington Fault has moved on an average of 0.16 millimeters per year over the last 500,000 years, and it likely hosts an earthquake every few thousand years. For comparison, the San Andreas Fault is estimated to move 30 to 50 millimeters each year, with an average time between earthquakes of around 150 years. This thing is the slowest horse on the racetrack, says Scherer. The party's over and everyone goes home before this thing comes back to the stables, but that doesn't mean it doesn't come back. That is, while it's slow moving, it shouldn't be ignored. For one, there's a type of motion thrust faults produce, which is more of a vertical shove than a horizontal back and forth of a strike slip. Wolf says, buildings can sway a little, but the up and down motions can be devastating. Such intense impacts were seen during the magnitude 6.7 Northridge earthquake that rattled from a blind thrust fault in 1994, killing more than 60 people and injuring thousands. The Wilmington Fault is also located directly below two important ports and other infrastructure, Shaw notes, and a disruption of operations could have major impacts. While more work is necessary to further tease apart the Wilmington's earthquake potential, the latest study emphasizes the importance of studying slow-moving blind faults. While we're all focused on strike slip faults, which come to the surface, Goldfinger says, the LA Basin's evil twin hiding in the subsurface might be just as jealous. Anyways, you guys, hope you enjoyed this little update. The article will be posted below the video later. I hope you guys are having a great day or night wherever you are in the world. Much love.